mainly during the software development is ensuring that the designed software product is same as specified. Verification is not substitute for the design validation. So that first verification comes, then this validation will going to follow the successful design verification. If we got to know the issues at the earlier stage before finalizing the plan, then it would be easy in order to develop the error-free system. Hello everybody, a warm welcome to one and all. Welcome back to the session 4 of Unit 3 B.C.A 6th semester subject called Software Engineering. I am Rohini T.S. Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So in the Unit 3, there we are learning regarding this design concepts as well as coding. So in the previous session of this unit, we have discussed regarding function-oriented design. So in that we got to know that how this design will going to be depend on the function of a system, and also have discussed regarding object oriented design, in short that is OOD, and also we have got the difference between this function oriented design as well as between the object oriented design, and also have discussed regarding how we are going to design a verification and validation process. So under that we got to know regarding this validation process. So in our today's session we are going to see about the design verification, how this design verification will going to be done. Already we know about the validation, what is validation and what is verification. Along with that, we will see the difference between those two, that is what between the verification and validation design, and also we will see what are the processes we have in a verification as well as in the validation process. And by seeing all these points, we will see what are the advantages we have when we have this validation and verification of designing. So let me get into the session, that is with respect to design verification. So in the validation, what we are going to do, we are going to check against the requirement of a customer whether all the requirement had met or not. So in the verification, this will going to done by the developer. So at the time of development, they will going to check against the requirement which is given by the customer. Are we producing or are we manufacturing the right product? That means what? They are checking against the requirement which is given by the customer. This verification will going to be done by the developer, and validation will going to be done by the user. They will evaluate whether all the requirement has been met or not. So in the design verification, it's a method to confirm if the output of a design software product meets the input specification by examining and providing evidence. So here we are checking whether we got the output as per the input. So whatever the input that we have given, are we getting the proper output for that? For example, if the input is 2 plus 3, or else if the input is 2 and 3 and the procedure is addition plus, then at last what we are going to get? 5, right? So there I am checking whether it is getting the resultant as per the requirement of the input. That process is called, that methodology is called what? Design verification. And what is the main goal of having this design verification here? Mainly during the software development is ensuring that the designed software product is same as specified. So if we are asking for upma, at the resultant we have to get the upma itself. That is what we are checking. I am asking for this requirement, are you satisfying this requirement? That is what? Verification we are checking, or it ensures that the designed software are produced is the same as specified. So if you are saying the construction team to build 3 floors, after that we are going to check whether they have built 3 floors or 4 or 2. That means what? We are checking against the input. That is design verification. And also here design input. So in order to build any of the thing, or in order to do the design verification, we require a design analysis has to be done, and also we require output. Then what we are going to give as an input? In the design input, that can be any physical and performance requirement that is used as the basis for designing purpose. So here we are going to give physical or any of the performance requirement as an input. Then what we are going to get as an output? It will be the result of each design phase. So in each module or in each design, what we are getting as a resultant, along with that at the end of total design effort. It will produce us the result by taking the input as physical and performance requirement. By taking all the requirement, it will going to do the processing. At last we will able to get the resultant. So that resultant will going to be produced in each of the design phase, and totally it will going to give the design effort as a resultant, so that it will always basis for the device of master record. So if I am getting a resultant for module 1, resultant for module 2, all those are integrated together, then we can get the device master record. It will going to have a complete system designing by incorporating all the module design. And also here you can see that we got to know what is verification and what is validation. So now we'll see what are the differences we have with respect to design verification as well as validation. This will going to be done based on different activity which will going to be performed at the time of SDLC or software or a system development life cycle. So here you can see that what brief discussion or brief difference between design verification as well as validation. So this is also very important question from this unit. Now we'll see the first difference. Here design verification is used where the actual design output should be same as expected design output which satisfy the specification of the product. Here what it must be mainly expectation versus reality should be same in the verification. So we are making a comparison between the actual design output with the expected design output. Both must be same. But when what will going to happen in the design validation? So here it is used to define that final design is as per the expectation of the user need. It will be more focuses on what? Based on the requirement of a user. Whatever the requirement which is given by the user, based on that requirement, this will going to be validated. And also mainly one question will be going to be asked in the design verification. What is that? Did you design the product right? Now prepare ಮಾಡ್ತಾರಾ ಪ್ರಾಡಕ್ಟ್ ಕರೆಕ್ಟ್ ಆಗಿದೆಯಾ? ಸೊ ಹಿಯರ್ ವಾಟ್ ಇಟ್ ವಿಲ್ ಬಿ ದ ಕ್ವೆಶನ್, ಡಿಡ್ ಯು ಡಿಸೈನ್ ದ ರೈಟ್ ಪ್ರಾಡಕ್ಟ್? ನಾವು ಕರೆಕ್ಟ್ ಆಗಿರೋ ಪ್ರಾಡಕ್ಟ್ನ ಡಿಸೈನ್ ಮಾಡಿದೀವಾ? That is what the difference between this design verification as well as validation. So here it is a question mark. Are we producing or are we designing the product right? Now prepare ಮಾಡ್ತಾರಾ ಪ್ರಾಡಕ್ಟ್ ಕರೆಕ್ಟ್ ಆಗಿದೆಯಾ? And then here ನಾವು prepare ಮಾಡಿದ ಪ್ರಾಡಕ್ಟ್ ಕರೆಕ್ಟ್ ಇದೆಯಾ? That is what the difference between design verification as well as validation. And also design verification will going to include unit and primary integration level testing. So here in the design verification we are going to build a small modules or designing of that small module will going to takes place. So for that reason here we are going to have a unit testing and integrated testing. So for example module 1 will be tested and module 2 will be tested. By integrating those two, it will check for the compatibility. Only that two levels of testing will be done. But here in this validation, secondary or higher level integration along with that main one, that is system level testing is also going to be done. By integrating all the modules or main modules, we can have this software system level testing, and all the higher level integration testing is also going to be done in the validation. Next point, design verification. So there certain aspects of design validation can be accomplished during the design verification. So some of the processes of this validation can also be done in the verification, but whatever the activities should be done in a verification cannot be done in the validation process. So that's why verification is first, then validation is next phase. So that you can see here, verification is not substitute for the design validation. So that first verification comes, then this validation will going to follow the successful design verification. So verification will be first and validation will be the further process. But whatever we have left out in the verification can be done in validation. But whatever the things that we have left out in the verification cannot be done in the validation. And also design verification can be conducted on the individual module or on the completed system under any condition. So here we can do the verification for a particular module or by integrating all the modules together. But validation, it shall be conducted under a specified condition as per the user requirement. Their main focus is on the user requirement, and whatever the requirement they have given, based on that scenario only they are going to check for the condition. So we want only 3 floors. That is what the user requirement. Based on that requirement only they are going to do the validation. But in the verification, they want kitchen, they want washroom, they want foreign toilet. If they are specifying all those modules, based on that they are going to have the integration, and individual modules will going to be tested separately. We'll see the last point. So here in the design verification, that can be of what? Static technique, that will going to include inspections, analysis, and also formal verification like testing activities. But when it comes to the design validation, it will going to consist the final report. That is what mainly we are going to have a test execution result that will be saved, or that will going to be done in the validation phase, and also that are reviewed and approved. Along with that, it needs to be signed. It will going to be considered as a document which we are going to use for the future reference. So these are the differences what we have with respect to design verification as well as design validation. We'll see the next one, that is regarding design verification process. Then how this design verification process will going to take place? First, we have to do the identification and preparation. First, we have to identify what is the expectation from the particular system. Then we need to start working towards the actual system. So, in the identification and preparation, in this development stage of a specification, the identification of verification activity is done in parallel. So, if a user is giving one requirement, in parallel they are going to do this verification activity, so that if it is doing parallelly, then it will be easy if the number of requirements are more. So that verification and specification both will going to be done in the parallel manner. So mainly this enables the designer to make sure that the specification is verifiable. So simply they can't take all the requirements which is given by the customer. They have to do the verification whether it is feasible to implement or not. Based on that, they have to do the further phases, so that a test engineer can start detailed design, test plan and procedures. So here, once all the requirements or specifications are verified in the process of verification process, then after the verified specification, so it will going to be done by test engineer, which will be helpful in order to have this specified or specification whatever they have given is verifiable. Only verifiable specification will going to be included in the test plan as well as in any of the further procedure. Next, if any changes in the specification needed at that time, that needs to be communicated to the designer. So if they have left out all the changes or modification which is not done, then it will be difficult. So that if ever whatever the specification changes that we require should be communicated to the designer, and mainly we have to identify the best approach to conduct the verification. So on what basis I need to do the verification? On what parameter should I reject the certain specification? So we have to identify a good methodology or approach in order to identify or to conduct the verification, and also in order to define the measurement methods. As I told earlier, on what basis I need to accept or reject the specification, that needs to be measured, and required resources, tools as well as facilities. In order to have all these at its best, then we have to choose the best approach to do all these methodologies or all these activities, and then the completed verification plan will going to be reviewed with the design team to identify the issues before finalizing the plan. So here we are taking some specification from the customer as a requirement, then that needs to be verifiable. So once it got verified, or when we are done with the completion of verification, at the time that will going to be reviewed with the design team. So design team will going to review all the verified specification which is given by the customer, and there they will start picking or they will start searching for the issues. So if we got to know the issues at the earlier stage before finalizing the plan, then it would be easy in order to develop the error-free system. That is what this first stage, that is identification as well as preparation. So if this got over, what they have to do in the second phase, that is planning. So in the planning phase of a software or system under the test shall be documented in scope. So in this we have to do the planning. So what are the requirements we have, how it will going to work, and what is the software or system under the test, that all needs to be documented. So when we have that documentation, when we have a proper planning of a test cases and how it needs to be flow, then it will be easy. So that in the preliminary test plan and a test plan refinement are made at this stage. So in the planning stage of a verification, it will specify a concurrent activity with a core and development team. What is the concurrent activity? What are the activities which is taking place parallelly? What is the concurrent? That means which is executing at a particular time. So that activity needs to be specified with a core, which is more important, which is more prioritized along with a development team, so that this occurs throughout the project life cycle. So this planning is not like a static. So if user come up with a new feature, that needs to be planned as per the requirement of a customer, so that it will going to be updated as soon as when their changes are made to the particular design inputs. So that needs to be flexible in nature to incorporate all the changes whatever is given by the customer. So if it does so, then it will be easy for the preliminary test plan. In order to write a preliminary test plan and test plan refinement are made at this particular planning stage. So if it does so, in the test plan, that will going to capture whatever the issues that may be faced at the stage of development, and also it captures the critical milestone which is going to be faced in a future. So if we got to know this critical milestone in early stages of a development, at the time that will going to reduce us a project risk. And also we have certain tools, test environment, development strategy, and identifying the requirements through the inspection or analysis. This is what we have to do in the planning. So now identification and verification over, and based on the planning, what are the test cases we need to have, and what is the software and system which needs to be documented. If we got to know, or if we planned for everything, then we have to do the developing, so that the test case whatever we have, that is what test case development will coincide with the SDLC or a software development life cycle methodology implemented by a project team. So this development team or a developing stage or a phase will going to be done by the developing team. A variety of test methods are identified during this stage. So here we are going to identify all the 360-degree of designing. So here we will be focusing on the design input, what is the design output, how the link will going to be established, how we are going to do the developing, what programming languages we are using, everything will going to be specified, so that the design input must be developed include simplest verification activities which are unambiguous and verifiable. So here what kind of design inputs that we have to take? It must be clear. That means it should be unambiguous. So error free or a confusion free, and should be verifiable. Only if we have a verifiable specification, then that can be used for the development. So that verification time shall be reduced when we have a similar concepts are conducted in a sequence. So when we are having a same sequence of work, or when we are having a similar concept of work, then it will be easy at the time of verification. So it will also going to reduce the verification time. And also even the output of one test case can be used as an input for subsequent testers. It will be in sequential form, right? So output of unit 1 will going to be the input for unit 2. So it will be in the sequential form. And also this tractability links are created between the test cases and corresponding design input. So all these inputs are specified, and also it needs to be verified whether we are having all these input as per the test cases. That needs to be checked once. If so, then that will going to be include, mainly to ensure that all the requirements are tested. So if we have missed any of the test cases or any one of the phase of a test cases, then we would end up with error. So that needs to be tested, and the design output meets the design input. So here requirement whatever it's given should match with the output. So expectation should be matched with the reality. So once the development is over, then what we have to do? Execution. So now system is developed, designed, everything is got over, then that needs to be executed. So here the test procedure created during the development phase is executed in accordance with the test plan. So whatever the developed system we have, that has to work according to, or that has to execute according to this test plan, mainly following some of the verification activity. So what if we have some invalid result occurs? So at that time, or any procedures required modification, it is important to document the changes and get proper approval. So I am done with what planning, development got over, then now we started working with the execution. So we are checking the output with respect to the particular test plan. So we are executing it. But what if there is an error? At the time, if there is any invalid test cases, if test cases is not matching with the expectation and reality, at that time that changes whatever we are making for a system or a design, that should be incorporated in the document, and changes whatever we have made should be get approved. Then only we can go with the further things. So any issues are identified and logged as a defect at the particular stage called execution. So when we are facing errors, and the reason for all those errors will going to be saved in the document. And also here we are going to use a tractability matrix that mainly specifies and verifies that all the design input identified in the verification test plan has been tested and determine the pass ratio. So if I have 100 inputs, then what is the resultant? If I have 1000 input, what is the resultant? So I need to test for the passing ratio or pass ratio. So if I have 100 input, how efficient it is in order to produce the output. So if it is 10,000 input, what is its potentiality? So that is regarding pass ratio. That needs to be verified in this execution. So now execution got over, then we must have a report. So in this reporting activity is performed at the end of each phase of verification execution. So in each execution end of phase, at the time that needs to be reported or should be saved as a document. So in the design verification report, that will going to give us a detailed summary of verification result. It's like a medical report. It will going to give you a complete details of a particular test that you have taken. So here in the design verification report, it will going to give a complete or a detailed summary of verification results, and that will going to include configuration management, test result for each type of testing and issues that found during the verification activities. When we have this design verification report, that will going to include all the activity, whatever we have done, how the configuration management has been done, what are the test results we have for each type of testing. For example, unit testing, integration testing, and also we have a system testing. For each testing, whatever we have, all the test results will going to be stored, and whatever the issues or errors that we found during that time is also going to be deposited, or it will going to be traceable in the reports. And also the traceable activities, that report is created between the requirements and corresponding test results to verify all the requirements have been tested and provided with appropriate result. So whatever the test cases we have, whether it is pass or fail condition, all those requirements will going to be saved in the reports. These are the stages, or these are the phases what we have in the design verification process. Next, let me move to the design validation process. So in the design verification, so we have what identify and verification is over, then they are going to do the planning. Based on the planning, they will do the developing. So once it got developed, that needs to be executed. If the execution is done, at last that should be stored as a report. Then what we are going to do in this design validation process, We'll see here, some of the design may be validated by comparing with a similar equipment performing similar purpose. So, if you go to a market, you are just going to make a comparison between the shops. So, this shopkeeper is giving a apple for 180 rupees, another shopkeeper giving a same kind of apple for 160 rupees. So, shall we go with 160 rupees? That means in the validation, we are making a comparison. Are we getting a product right? That means we are checking whether we have met all the requirements based on the customer or based on the requirement of a end user. So, in the validation process, it will going to compare with a similar equipment which is performing a similar purpose. So, in order to identify the potentiality of each methodology to satisfy the same requirement, then which will going to be best, in order to get to know that, we are going to have this validation process. Mainly, this method is particularly relevant for validating the configuration changes for existing infrastructures or standard designs that are to be incorporated in a new system or application. How it was working with a existing system, how it will going to be work with a new system or upcoming system. So, all those phases needs to be compared and should be analyzed with this validation process. And also, this demonstrations or inspection may be used to validate the requirements and other functionality of the product. Then how can I make a comparison? What are the methodology I am supposed to use? So, in that, when we have a demonstration or inspection, so then I need to find its relevant potentiality. At the time, we are going to use this two methodology, demonstration or inspection, that will going to be used in order to validate the requirement which is given by the customer, and also the functionality of a product. What is its functionality? If it is existing one, what are the functionality of that particular product? Everything will going to be tested or validated. And also analyzing the design. So, how can I analyze the design? So, that can be done with the help of mathematical modeling, and also we have a simulation. So, with the help of simulation and mathematical modeling, we can do the analysis of design. So, here demonstration and inspection, and also we have a analysis, and next tests are going to be performed on the final design that validates the ability of the system to operate as per the specified design. And also we are going to have a test that specifies whether it is working as per the requirement which is be given by the customer, whether all the requirement has met or not. So, that is what we are going to do in the validation process. Along with that, test plan, execution and result should be documented. So, whatever we are doing, whatever the changes that I wanted to incorporate, everything should be saved in a document and should be maintained as a part of design record. Why? Because if I wanted to have any of the changes, his modification needs to be takes place, at the time this documentation or a record will going to help us a lot. So, that validation is a collection of the result of all the validation activities. Very, very important. What is verification and validation can be as for 2 marks. So, here what is validation then? It's a process. It's a collection of all the results of the validation activity. So, whatever the validation activity that we are doing, that can be with respect to analysis, designing or testing. So, all are the validation. So, whenever we having that validation activity, all the activities should be stored as a document, then we are going to call that as a validation. So, this is what regarding design validation process. So, next you can see one of the example to make you understand how this validation process will going to takes place. So, let me consider one simple product, that is what waterproof watch. So, here we have a product called waterproof watch. So, the product requirement. So, what is the product requirement here? The watch must be waterproof during swimming. So, when we are inside of water, at that time that watch needs to be waterproof. That is the requirement. Then what will be done in the design specification? That specifies that the watch should function even if the user swims for a prolonged time. So, when the user is in the water for a long time, at the time that watch should be function as a waterproof. and this is related to what? Product requirement, and we have a design specification. Then how the testing result will going to be confirm the requirement with a expected or with a resultant product, so that confirm that the what should meet these requirement, else the redesign iterations are done until it satisfy the requirement. So if the waterproof watch is working properly under the water for a long time, then that is satisfying the requirement of a customer. That will going to be validated against the requirement which is given by the customer. So these are the example that you can expect. Next, we'll move to the advantages of this validation and verification process. So together we got to know that we have a V model, and here we have a verification, we have a validation. If the verification is done, then we have to move with a validation. For example, you have a requirement 1, requirement 2 and requirement 3. So this will going to be verified by the developer. So in the time of development, this requirements will going to be verified, that is in the stage of verification. So once it is developed, once it is built, at the time against the requirement of a customer, whatever the design product we have, design system we have, that will going to be validated. So it will check all the validation activities which has been done in order to satisfy the requirement of a customer. So we will see the advantages whatever we are going to get with respect to validation and verification process. So we can continuously monitor the designs which enables us to meet the user defined requirements at every stage. So here we are going to keep on verifying and validating all the requirements of a customer in all the stages. So that will going to be very helpful in order to monitor the design. And also validating the design will point out the difference between how the functionality works and how it is expected to work. It's like a what? Expectation versus reality. So what we are expecting, how it is working, then that will going to be get to know at the time of validation. And also documenting the validation procedure will help to easily understand the functionality at any stage in the future if there might be any change or enhancement made. So here once the system is built, so if we are having all that as a document, then it will going to be helpful in a future if you wanted to do any of the changes or a modification. And also this development time will be consistently reduced by improving the productivity, which enables to deliver the product as expected. So when the development time is less, so when the verification and validation both are doing in a parallel manner, then it will reduces the development time so that the productivity will be very high, so that it will going to improve the productivity. If we improve the productivity of developing a product, then that will be helpful in order to deliver the product as soon as possible. And also this process includes range and scope of each validation methods that are required to be employed. So here whatever the methodology or a range and scope, so what is its boundary? So by analyzing that, we will be able to do this validation in a great manner. And also the validation can be carried out using detailed design data that represents the final user requirement. Moreover, we have to satisfy the requirement of a user. So that final user requirement will going to be satisfied by using detailed design data. And also any difference between the outcome and the user needs, documents must be captured. So if there is a difference, so this is what user expected, but they got the different resultant. That mismatch between the expectation and the actual system should be reported in the record. And the changes whatever we have done in the validation design, that will going to lead to the revalidation activities. So whatever the revalidation is done also, that needs to be saved in the report or a document. And also it is important to document every activities that occurs during the validation, whether it is verification, validation, whatever the changes we are incorporating, every detail should be stored as a document, which will going to be adequately proves that the designer meets the user requirements. If you don't have a proof, then user won't believe you that that means this was working as per their requirement. So maintaining all the documents with respect to any of the activity is also going to be very helpful. These are the advantages that you can expect from the validation as well as verification process. I hope you all understood. It's all about today's session. So till now we have got to know regarding feasibility study, and also requirement gathering is over and requirement specification is also over, that is SRS. After that, analysis has been done by the analyst. Once it got analyzed, that needs to be converted into some structure, that is what designing. So in the designing we have a verification, validation, all those things has been done. So now in our coming session we are going to go with this coding or implementation. What are the different methodology we have in order to do the coding, what are the programming languages can be used in order to implement the design document will be the topic for my next session. Let me meet you in the next session. Until that, keep learning, keep on growing. Thank you.